Hi, today we are going to talk about center of mass. The very first thing I want to talk about is the definition of center of mass. If you look at the equation, it is mass times position of each individual object, all add together as numerator, divided by the total mass in denominator. You should realize that we can find the center of mass not only in the x direction but also in y direction. You should find them separately. Here is a simple example in one dimension. It is vitally important to find the origin for the center of mass problem. Here we treat the two balls as point particle, means we don't care its size, shape, and structure. Firstly, we choose the position of 2 kg ball as the origin. Thus, the position of the 1 kg ball is x equals to 8 meters. Then we can apply the equation 2 kg ball as m1 and the 1 kg ball as m2. Thus, at x direction, 2 kg ball at the origin plus 1 kg at the x equals to 8 meters, divided by the total mass 3 kg. Then we got the result is 3.3 meters, somewhere near here. Let's see two-dimensional. There's a third ball that's placed 3 meters above the 2 kg ball. We still choose the position of m1 as the origin. Based on 3 ball, we can see both m1 and m3, the x position is 0. So it equals the mass of the m2, 1 kg, times its position, 8 meters, over the total mass, 3 kg plus 1 kg plus 1 kg. The result is 1.3 meters. Likewise, in the y direction, we can see both m1 and m2, both its y direction is equal to 0. Then we only have to calculate the y direction of m3. Thus, the center of mass in y direction is 1.5 meters, so the center of mass is somewhere near here. The third example, I'm going to talk about the continuous body. Thus, we have to consider its size or shape. Here we have a uniform density L shape, which has upper end 6 meters long and lower end 4 meters long. I want to find the center of mass of its L shape. Because the uniform density, we assume each piece has the center of mass at its center. In other words, if I look at the upper part of L, which is 6 meters tall, means the center of mass of this part is at y equal to 3 meters. That is the beauty of the center of mass. I can pretend that the mass of the system is concentrated at this point. Likewise, for the lower part of L, the center of mass is at x equals to 2 meters. Well, when you look at the equation, you may say we don't know the mass of each part, but it tells you the uniform density is useful. It means if we have same density, that the mass has the same ratio. The length has the ratio of 6:4, then the mass must have 6:4. If I choose A as mass of 1 meter segment, then I would say the upper part is 6A. Then the mass of lower part is 4A. We choose the corner of the L shape is the origin. Then we apply the equation. We find out the center of mass in x direction is 0.8 meter, and in y direction is 1.8 meter. Somehow is near here. Here is another trick for the uniform body, that the center of mass must at the line connecting to the two parts of center of mass. Well, if the body is a symmetrical body, for example, a T-shape, I would say there is a symmetrical line here that the center of mass must at the line. We also can use the trick in L shape that we have no mass of the lower part is here and in the upper part is here, so the center of mass must somewhere between the line. Okay, that's all for today. If you want more resources, more lessons, please join the QQ group.